Welcome to the course Cortical Bone Mechanics. I am Dr. Revati, Assistant Professor, Department of Biomedical Engineering, Dr. NGP Institute of Technology, Coimbatore. Bone is an anisotropic, heterogeneous, inhomogeneous, non-linear, thermorheologically complex viscoelastic material. The most important feature of bone material is its stiffness. Anisotropy means its material property changes with direction. Bone is anisotropic because it's stronger and stiffer along its longitudinal axis and weaker in transverse or radial directions. Bone is both heterogeneous and inhomogeneous material because it has different material such as collagens, hydroxyapatite, cells, etc. It is inhomogeneous because its structure and density vary across regions. It is a thermorheologically complex material. It consists of different components like collagens and minerals. These react to the temperature differently. Bone consists of viscoelastic behavior. That is, collagen gives its elastic stretch. The fluid and organic matrix causes viscous flow over time. Cortical bone is also called as compact bone. This is dense, hard outer layer of the bone. It forms the shaft of long bone called the diaphysis and the outer ends called epiphysis. It provides strength, stiffness and protection, especially for long bearing. Mechanical properties of cortical bone. The elastic and strength properties of human cortical bones are anisotropic. When load is applied along the length of the bone, it can withstand higher force. It deforms less under those forces. This is called as stiffer. When the load is applied radially, that is from the center, or circumferentially, that is around the surface, it becomes weaker and more flexible. Cortical bone is also stronger in compression than in tension. Human cortical bone is a linearly elastic material. That is, when the load is applied, it changes its shape. When the load is removed, it comes back to its original position. However, when the cortical bone reaches the yield point, even though it's unloaded, it undergoes permanent deformation. Cortical bone is relatively weak under shear stress and tension. Aging also affects the mechanical property of cortical bone. Tensile ultimate stress decreases at a rate of approximately 2% per decade. Cortical bone has a greater resistance to fatigue failure under compression than in tension. That is, it can withstand repeated compressive loading while walking, standing and jumping. When cortical bone is loaded repeatedly for a long time, it may deform slowly, that's called as creep. It weakens progressively, that's called fatigue. Thank you.